Hello wonderful person, this is Anton, and in today's video we're going to be talking about what's known as an eyeball planet. Now, it might sound kind of science fiction-y, but in theory it's actually the most common planet in our galaxy. Welcome to What the Math. So when you look at our planet Earth, it seems very familiar, and it seems like every planet out there somewhere in the galaxy is going to be similar to it, or at least we hope so. Turns out though, as we study our planet and exoplanets a little bit more, Earth, the way it's formed and the way it is and the way it's structured and what's on the surface and inside of it is actually extremely rare. It's super rare to find a planet like Earth. The most common planet in our galaxy, as of the current understanding of exoplanets, is actually what's known as an eyeball planet. And I'm going to show you right now what the actual planet looks like. And I'm going to take you to a system where we think there's like tons of these eyeball planets. And it's actually a system we've talked about previously. Now, this is the system I'm talking about, and if you haven't guessed yet, this is TRAPPIST-1. The system discovered just over a year ago when I'm making this video, that basically has 7 terrestrial planets, or terrestrial in quotation marks. Let me actually show you the structure of such planet first, by showing you the structure of these planets from the outside first. And this is kind of what these planets look like. Now, it may not resemble an eyeball just yet, and it might not actually make sense why it's called an eyeball planet, but if you were to look at it from different angles, you would realize that it actually has very different structures on the surface. As a matter of fact, it has extremely hot surface right here at all times, and extremely cold surface here, once again, at all times. And it has relatively temperate area right here on what's known as the twilight area. Now, this particular eyeball planet is known as a hot eyeball planet because it basically has desert or desert-like conditions on the warmer side and pretty much really cold, icy conditions on the other side. There's another type that I'm going to show you right now, and the best example here is TRAPPIST-1F. This is called a cold eyeball planet, and you can probably tell why. It basically has ice shelves here, and also obviously on the dark side, and essentially liquid water facing the star itself. And as you can see, simply from the actual visual representation, these planets are very unique, very unusual. We don't have anything similar in our own solar system, but they are extremely common simply based on one simple fact. These planets are the most common planets around what are known as the red dwarfs, which is the star that you'll see in a few seconds. That's a red dwarf. These are the most common types of stars in our galaxy. Something like 90% of all of the stars in our galaxy are red dwarfs, and the vast majority of them have planets, and most of these planets are usually similar to this. They're terrestrial in nature, but eyeball looking in appearance. Now, if you were to actually go a little bit closer, you'd realize that this side is always hot, this side is always cold, and this is the only side where you could potentially kind of have livable conditions because it's moderate, and this is where you would most likely find any kind of signs of liquid water. Although for cold eyeball planets, you might also find liquid water on the sun side because here the temperatures are just really cold in general. If you were to try to dissect the actual structure of these planets, this is kind of what it looks like. So first of all, why are they like this? Well, it's because all of these planets are tidally locked to their star. In other words, as they are rotating, only one side is facing the star and the other side is always dark. It's kind of like our moon, I guess. When you look at our moon, you always see the same face, or pretty much any moon of Saturn or Jupiter. Most of the moons of Saturn and Jupiter are tidally locked as well. Light comes from the star here. This is, let's say, TRAPPIST-1. And as the light comes in, it obviously heats up this part of the planet. So for most of these planets, they're going to be extremely hot. This is going to be desert-like conditions, extreme temperatures. And the other side, since it's always dark, is going to be pretty much ice. Now, assuming that there is any kind of atmosphere on this planet, it would actually create a relatively active, essentially, circulation here that would circulate the planet and most likely warm up this part as well. So it's not going to be super cold, but it's still going to be relatively cold. And it will actually create lots and lots of clouds in this area, so the darker side of the planet. And there's going to be most likely either very few or very unusual clouds on the hot side of the planet. All of these planets will most likely also have quite a large ice shelf, and there's going to be a very, very unusual area right here on the what's known as a twilight zone or twilight area, where there's going to be quite a lot of liquid water as a kind of a band around the planet. And if it's a cold eyeball planet, it's also going to have more water pretty much everywhere here. Although the other side of the planet is going to be much, much colder and more inhospitable to life and habitation. Now, TRAPPIST-1F is actually a really exciting planet for us to learn more about because it might potentially have quite a lot of liquid water on the surface, simply based on the density studies we've done so far, and simply based on the fact that if it has one side always facing the sun, it's going to be warm enough to create liquid water, assuming that there is some kind of atmosphere here. It doesn't mean that it's going to be habitable to humans because it's most likely going to be a water world with a lot of ice, unless of course you're okay living in Antarctica-like conditions. And it's also going to be really dark here, but it might have potential conditions for life. On the other hand, all of the other TRAPPIST planets, especially the ones that are closer to the star, are most likely going to be similar to this, which is the hot eyeball planet. And so here, you would most likely expect a very large desert-like area facing the star, with relatively temperate conditions on the twilight area, with water starting somewhere over here. Now, the reason why these stars are actually kind of important to study, and hopefully one day we'll even make it here, and the reason why these planets are so important to us as well is because, first of all, these are the most common types of planets, thus making the chance for finding life on these very, very high. On the other hand, these types of planets are also the ones that are going to stay with us the longest. Red dwarfs are the longest living stars. Their lifespan is over 1 trillion years, which is like hundreds of times more than a sun-like star. And so these planets in the future, if the humans are still around, might actually become our new home. So we need to learn more about them, and we need to find out if we can actually create habitable conditions on these planets, because it's important for our own survival as a species. Now, for now, that's all I wanted to talk about in this video. So now you know a little bit more about these so-called eyeball planets. And in one of the future videos, we might even try to make an estimate of how many such planets there actually is in our own galaxy. And the number is going to be completely outrageously large. So there's definitely going to be at least one of these planets that we're going to find that's going to be just perfect for humans. Hopefully in the next few years we'll discover more and more of these planets similar to TRAPPIST-1, and hopefully we'll even discover something else unusual about them. But for now, that's all you need to know. It's a type of a planet that's not available in the solar system, but is actually extremely common in our galaxy, making, once again, Earth an extremely weird, yet unusual, yet wonderful place to live on. So chances of us finding Earth-like planet is actually relatively low, but chances of us to find an eyeball planet that's relatively similar in at least temperature to Earth is pretty high. Anyway, thank you so much for watching. I'll see you guys tomorrow. Come back tomorrow to learn something else, and consider supporting this channel on Patreon, because it does help me make better videos and spend more time devoting myself to this channel. I'll see you tomorrow. Space out, and as always, bye bye.